All right, we're recording. All right, good morning, everyone. And let's see if I can get this pulled in. We've got rhombuses and kites that we're going to be focused in on. And we're going to take a few notes as we go. So get your paper ready. The first thing I want you to do is get your name written out. Now, I have to go quickly. I don't remember what today's date is. Losing track. Hang on. What date is it today? The 8th. Okay. So we got today's the April the 8th of 2020. Put it up here at the top so I'll know who you are. And let's go work on some notes here for just a minute on the rhombuses and kites. Now, remember, we're doing quadrilaterals, and quadrilaterals are basically four-sided figures, but in this case, this is a special quadrilateral where we have, what did it say? I think I remember the definition said something about adjacent, congruent. That's the two words that these two right here are adjacent and they're congruent. So that means that's a kite, okay? Adjacent and congruent. So those links are the same, and right here is adjacent and congruent. Those are the same there. And so now let's write down our definition here. It says the area of a rhombus or kite with diagonals D1 and D2 is area equals 1/2 D1 times D2. So it's very simple. All you have to do is look at your shapes here. In order to get the area of these two shapes, you take their diagonal lengths and you multiply them together, and then you divide them by 2. It's very straightforward, not much to that, okay? So now we're going to draw this out. I'm going to draw this the best I can. So we're going to make a rhombus that looks like this. Now, rhombuses usually have 4 sides that are exactly the same length, but in this case, I'm just going to just kind of quickly draw this. All right, so we've got this diagonal here and this diagonal here, just like you would see on any kite. Those are what we're going to be focused in. Now, I'm not going to worry about drawing this twice. This is all that really needs to be done. So it's a rhombus or a kite. It could be one or the other, okay? So now let's move on down and see what we got here for example number 3. All right. I'm getting a question. Hold on. I think it's page 591. That's where we're at. Page 591. The section is 9-1. I'm seeing the chat, guys, so I can read it down here. If y'all ever have any questions, please go down to the chat and type stuff in, because I'll see you instantly. That's going to be the fastest way for you to get answers from me, okay? So you're welcome, okay? And somebody just said, thank you. All right, and let's go down to the next part, and let's see what example 3 says. D2 of a kite in which D1 equals 16 centimeters and A equals 48 centimeters. If you can interpret what that says already without reading what we're trying to do, you've already got a good grasp of what's happening. You're going to take an area of a square, like a rectangular shape, and you're going to know one diagonal length, but you're not going to know the other diagonal length, okay? So it's possible they could give you this length, but they won't give you this one, and that's what you're trying to find. So you're basically solving an algebraic equation at that point. So in this case, we're going to do example. All right, so we're going to find D2 given, I'm going to come down here and show you what I'm doing. Given that D1 is equal to 16 centimeters and A, the area of the shape, is 48 centimeters squared. Okay, so this is just a more simple way or easier way of writing that out. So let's write out our formula for the area of a rhombus and a kite. All right, and so how do we know this is for? Because it says up here, we're finding the measurements of the area of the rhombus and kite. Okay, so now the area we're going to put in is 48. We're going to put our 1/2 right there. And then I do know D1, right? and I don't know D2, so I'm going to leave D2 just like it looks. Now, what is half of 16? That's going to be 8, okay? All right, so 8 is half of 16, and all you have to do now is just think, okay, what number do you multiply by 8 to get 48? Well, 8 times 6 is 48. If you divide both sides by 8 here, you get D2, which is the other diagonal, which is 6. So what would that look like? I'm going to draw this out and just kind of show you. So in other words, I've got one diagonal is really long. It looks like this. Let's say that's the 16 there. So from here to here, that's one diagonal. And then from here to here, let's draw a 6. It's going to be kind of shorter like this. So let's say that that's 6 right there. All right, from here to here. So what would that look like? It would look kind of like a elongated rhombus or a kite, okay? All right, it's not a trapezoid either. I guess because now the reason it's not a trapezoid is because if you turn it on its side and you looked at it like this, these two lines would not be parallel. So that, and these two lines are not parallel. So on a trapezoid, you have to have parallel, at least two opposite parallel lines. So in this case, this is 6 centimeters for our diagonal. And the area, all this right inside of here would be 48 squares. So like if you were to square this off and you were to draw out all these little squares inside of here and count every little square, you would count 48 centimeters squared, okay? All right, that's what that means. All right, so let's go do the last page and talk about some notes here on the back. So far, what do our notes look like? Let me pause. You can pause your screen on YouTube if you're watching that, and then if you're watching it with me on Zoom, you're just gonna kind of have to run with me, all right? Because you can't really pause me live. You can tell me to stop, but who says I'm going to listen? Nobody. All right, so D is the diagonal. Somebody just had a question, see? D is what a diagonal is. So in this case right here, so let me draw a square just to kind of help you. All right, so we've got, let's say you got a square that looks like that. Your diagonal would be from here to here, right? So that's one diagonal. All right, and then if you look at the other side, you can draw another diagonal like that. Now, what they're saying is you can find the area of this. If you know the diagonals, you can multiply one by 1/2 by D and by both D's, D1 and D2. Okay, so so this would be D1 and this would be D2. Okay, I hope that makes a little more sense. But yeah, I can see your questions as you go. That's the fastest and easiest way to ask questions as we go. Yep. Okay, so it's good to see everybody. Good morning. I hate you're going through all this mess that we're having to go through, but hey, look, if I had this much time off and when I was in school, I would be jumping out of my socks, okay? So just enjoy the peaceful days, and if you need help, make sure you find help if you're needing help outside of school. Make sure you're asking for it, okay? Don't just suffer through this time without any help. It's okay to ask for it, all right? So let's go to the page 592, okay? Now, remember yesterday our time kind of zooms away from us, and we can't really cover a whole lot more than just maybe a page and a half of the material. So I'm going to try and walk you through this, but let's look at page 592, and I'm going to zoom in on this just a second. This is what I'm going to work on with you, okay? So we're doing the area of rhombuses and kites. So we have a rhombus here, okay? It's just a slanted rectangle. It's like, think of a barn that's been pushed in the wind off to the side with this leaning, right? And then over here, we've got a kite. So that's what you would fly in the air. If you had a string, you could fly it if it was a windy day. And so you're going to use the same formula for both of these, okay? I'm trying to get this cleared up, but the sun keeps poking out of the clouds. It messes me up a little bit. All right, so first off, you've got these two. I'm going to admit a few people in here. Okay, so I've got these two diagonals that they give me of this. So like if I had a barn that was pushed over, you could find the diagonal here and here if you had a tape measure. You could also find the diagonal here and here, which would be longer, by the way. And you would, if you wanted to find that this, like how big of a door to make your barn door, how big of an area to make that barn door to cover this gap right here, you would multiply D1 by D2 and then divide by 2. That's what this formula says right here, okay? So we're going to go through, and we're just going to do another example, okay? Now I'm going to split this into two, because I'm going to do two examples here. So get your note takers in gear, and let's get rolling, okay? So remember, we're going to use this formula here, and we're given that D1 equals, what did we say? D1 equals 6x plus 4, all right, and D2 equals 10x plus 10. Okay, so we're going to use these two things that we're trying to figure out, and if you'll notice in the equation here that the area is never given. There's no real number for that, so they just keep that A. We're going to come up with what's called a trinomial answer here. So you've got two binomials that multiply together to make a trinomial. Y'all seen this before. It's called FOIL method is what we're fixing to use. Okay, all right, now y'all saw this in algebra, I remember. Us talking about that before, okay? So here's your equations. Now I want you to understand something. You see how these are both even here and these are both even here? You could do something very neat, easy here, and that's a little different than what they've got going. Okay, so you can actually take part of this. Just like if you were to take 6 and divide it by 2, what would you get? You would get 3, right? So 6 divided by 2 is 3. Well, what's 4 divided by 2? 2, right? And if you've already taken care of that, then you only have to do it to one of those. Well, let's just, I'm going to do it the way the book does it. I just wanted you to understand that there are other ways to do this. So let's do FOIL method. So I'm going to draw a line from here to here. That's called first, all right? Let's see, then we're going to do, what's 6 times 10? 6 times 10 is 60, x squared. X times x is x squared, okay? And then now we're going to do outer, which is from 6x to 10. So draw another line that goes like that. So you're drawing some like rainbow arcs here, okay? First, outer. Outer is going to be 6x times 10. 6x times 10 is 60, but this time it's just x, not x squared. Okay, this other one was x times x. This one is just x. So it has one x there. Now we're going to do inner. Inner is 4 times 10x, which is 40x. And then the last terms are from 4 to 10.
Bruh.
How these work out here. So we've got 4 times 10 is 40. Okay. Now, let's see what we can do here with what what's happening on the, if you'll notice here, we've got 100x in the middle. Well, how did they get that? They got that from right here. So if you'll notice, you've got two like terms that we can combine inside. So let's go ahead and do that. Let's write it out like they have it, okay? So we've got 100x, and then we've got 40 there. So now all we have to do is take 1/2 and cut everything here by half. 60 cut in half, 100 cut in half, and then 40 cut in half. All right, so if we rewrite this, we're going to get 30x squared. Then we're going to get half of 100 is 50x, and then half of 40 is 20.
Wait, if you do multiplication and division left to right, wouldn't you do the 1/2 to 6x times 4 first?
Or you're talking about 1/2. You could break this like I was saying. You could go ahead and take out that 1/2 by saying 3x plus 2 there, and then doing the FOIL method. But I just did it like the book did. You could actually do a couple of different ways. Don't worry about that. No worry. Okay. So just write what you see here, and we'll be good. All right. Let's move on to the next example. All right, so we got an area of a kite here. Same thing's going on. This time we've got a long diagonal and a short diagonal. We're going to multiply those two diagonals and divide them by 2 to get the area, okay? But there's more to this kite than it appears, okay? So let me see if I can zoom in on this. I want you to be very, very cautious about this because what this is going to involve the Pythagorean theorem. So this next example is going to be a little more thought provoking, I guess. So let's look at the diagonals D1 and D2, which form 4 right angles. So if you'll notice, they're talking about 1, 2, 3, 4 right angles. And we're going to use the Pythagorean theorem to find x and y. So what does that mean? So what do they mean by x and y? So if you look here, this x and this y all add up to make this long diagonal right here, okay? So if you'll notice here that this is 9, you know, technically you don't necessarily know that, but I'm assuming it's going to be 9. But really, you don't even need this down here to figure this out. What they're basically saying is, all right, here's 2 triangles. All right, let's cover this up. All right, here's 2 triangles. There's a 9, 41, X triangle, right? And then over here, you've got a Y, 15. Well, I suppose that is 9. It has to be because they showed it here in the example. All right, so this would be a 9, 15, and Y triangle. So these 2 triangles, I'm not going to draw on the book, but I could shade in this triangle here. That's important, and this triangle here. What am I trying to find? I'm trying to find the X value and the Y value. That's all that I'm needing to do. And then at the end, you'll know how long D2 is. D1 is 9 plus 9, which is, you see this, 18. Hold on, my dog's barking over. Give me just a second. I got a visitor here. Okay, so now I'm going to start recording again. We're about 20 minutes into the lesson, so we're halfway through. So what's going to happen is your notes for me today are going to be about twice this long. Okay, so let's go down here.
Wait, we've been supposed to have been taking notes.
Yeah, so make sure you take notes and then take a picture of it and then upload it as an email to me or through Microsoft Teams. One of my other students in Algebra 2 figured out how to upload his files to Microsoft Teams, and I can grade you that way, okay? Or I can show that you are proven. So that's what I'm trying to get at. So in other words, all you have to do is write down what you see, and that's it. I mean, I'm not going to expect you to do anything outside of that because I don't have. I mean, we're already working from home. It's already enough as it is.
Honestly, teachers like trying to get us to work from home. It's not really going to work out the way they think it is. It's like, because we're in an environment where we do nothing but eat, sleep, and I don't know what y'all's daily routine is. I just eat and sleep and then play on my computer. And then they're asking us to do work in that environment.
Yeah, it's not a ideal situation, but at the same time, we'll make it through this. We'll get through on the other side of this.
Oh, well, also.
Yeah. So don't worry too much about you know how things are going right now. You'll look at this in about 3 years and wish you were back here. Okay. So just enjoy it while you can.
True. Break do be kind of nice.
It's good to take a moment to take a deep breath and just recuperate. I mean, who knows? And we may find out later in the future that we really needed this time. You know, so of just relaxation. Okay, I think. Okay. Yeah. Okay. So now, let's go through just a second, and I gotta click on some things here. All right. Now, first off, I'm going to go back to this example, and I want you to notice that both of these numbers. Both of these triangles here are going to have to involve the Pythagorean theorem. So what I'm going to do is I'm going to write the Pythagorean theorem twice. All right. And so I'm going to write 9x and 41 here, and then 9y and 15. So I'm going to put 9y and 15. Now, why am I writing it like this? Why am I putting 41 here, and why am I putting 15 here? Those are the hypotenuse of these triangles. So those are the longest lengths, all right? So I'm going to put that here, and then the shorter lengths go on the other side, and you add those together. So let's do both of these at the same time, all right? Y'all ready to do both at the same time? All right, so let's see if I got a few kids popping in here. So 81 squared, 9 squared is 81, so I'm going to put that for both of those. I'm going to work smart and not hard. So I'm going to put x squared here and y squared here. All right, and so we're going to put 15 squared. What is that? That's 225. These are things that if you do this enough, you'll memorize these kind of things. And I'm trying to remember exactly what this one is. 14, I think it's 961. Let me double check that. All right, 41 squared, 41 times 41 is, I'm sorry, I was off, way off. It's 1681, okay? So 41 squared is 1681. All right, let me pull that off to the side. All right, and so now we're going to solve for the x and the y here. So we're going to subtract 81 from both sides. Okay. All right, and so what happens on the right-hand side is I get 1600 because the 81 cancels, and the square root of 1600 is 40. Okay. So now that's us. Let's go over to the next part, and we're going to subtract 225 and 81. So let's do that quickly. 225 minus 81 equals 100 and, I don't know if you can see this, 144. Okay. So, and we all know what the square root of 144 is. That's coming. So we've got y equals 12. Okay. So now what does this all mean? Okay. So if you put, remember, D1 is going to be equal to 9 plus 9, and D2 is going to be equal to 40 plus 12. Now, how do I know that? Okay. So 40 plus 12 is, well, how do I know that? Because if you'll notice here, X and Y, when you string them out, makes this long diagonal, and 9 and 9 makes this short diagonal, right? So that's where my 18 comes from, and that's where my 52 is, okay? So if D2 is 52 and D1 is 18, then I know I can multiply those together and divide them by 2 to get the area. So I'm going to write area equals 1/2 D1 and D2, okay? So area equals 1/2 18 times 52. And then just like we were talking with George earlier, 18 divided by 2 is 9. So this is 9 here. And you could handle that. Okay, so let's see what we got here. Let's see. Okay, so now let's go and talk about the part that we need to worry about, which is 18. Okay, let me see if I can do this real quick. This getting the sunlight. So second mode clear. If you have these kind of calculators, as TI-84, every single time you go, you use it, make sure you push second mode clear. I'll show you exactly what I'm talking about. Second mode and then clear. And what it does is it clears the screen back to normal here. And I do that every time. All right. So what's 18 times 52 and then divided by 2? That's going to be 468. Okay. You see that? 18 times 52 divided by 2 is 468. Now, what does that mean? That means that's the number of squares inside of this shape. If you were to mark it out with lines here and draw lines horizontally and vertically and count all the little squares, you would get 468. In this case, it would be feet squared. Okay. All right. So there's my final answer there. Now look, what do my notes need to look like? for the bottom half of your notes look like this. You can screenshot, if you're watching this on YouTube, you can pause it and then come back later. So, and write that down. And then the top half of your notes so far look like this, okay? So those of you who missed the first part of the lesson, we're on section 9.1 again, and we're around the page 592. And so make sure that you write your name at the top, and then when you get through with this, take a picture of it and email it to me, okay? We're now 28 minutes in. We've got about 12 minutes left, so we've got plenty of time to do a couple of practice problems, all right? Now, Monday when we get back, we'll jump right into 9-2, and now I'm going to go to a new page, all right, because I'm kind of running out of space here. So let's go over here to a new page, and let's do, oh, I'm sorry, scrap that. Go back to that page. We do have one other thing we need to talk about, and that's this example 4. I did not see this. We need to discuss this down here, okay? Example 4, my bad. Okay, yeah, guys, if y'all need to chat with me, just please type it in the chat room, and I'll be able to see if anybody has any questions or whatever. Okay, and so that's probably the best way to do that. Okay, so let's go. This is called a tanagram, and this is pretty interesting. I don't know if you've ever played with puzzles like this when you were younger. Piece little puzzles like this together, like you have little triangles and squares, and then this is a rhombus here. You put them together in such a way to make a square at the end, and you'll make mistakes if you slide them around and put them in the wrong place. That's called a tanagram, okay? And so in this case, we got a square. If you go through and count these squares, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. These are 16 squares for the area, but if you took every individual piece and found out the area of a triangle is 1/2 base times height. Base is 2, height is 1, 1/2 of 2 is 1. So if you put these two things together, that would be equivalent to 1 square. See what I'm saying? 1/2 base times height, 1/2 base times height, 1/2 base times height, base times height, 1/2 base times height. And so if you go through all that and add that all up together, you find out the area, but there's an easier way to do it. If you know the diagonal here, this diagonal here, and this diagonal here, if you know how much they are, you can multiply them together and get, and divide it by 2, and you get the actual area of the whole shape, okay? All right, so I'm not going to dig into that. I think I'm going to stop on that one. We're not going to do example 4. I just wanted you to kind of see how that goes with the area addition postulate that we wrote down 2 days ago. All right, so let's go over here. I'm going to write as much as I can. I'm going to try and finish out this little section. I'm probably not going to do this bottom section down here on page 593. So we're just going to go through and kind of hit the high points of each little part, and then I'll upload this to YouTube, and those of you who aren't with me can watch it later, okay? Or if you need to go back and watch it later, that's fine. Now remember, yesterday it cut me off, like it shut me off way before I was through, and so hey, that's not a big deal. Sometimes it'll do that. So I'm going to put GP for guided practice. This is the other part of my notes, and this is on page 593. Okay, and so we're going to do example number 1. All right, number 1, we need to find the area of a parallelogram. All right, I want to write this out. All right, and so the area of a parallelogram is base times height. So if I have a parallelogram that looks like this, and I've got a base down here, remember the height has to be at a right angle to the base. So that has to happen. So these are centimeters. So what's this going to look like? Number 1 is very easy. All right, you just put 12 times 10. That's 120 centimeters, but be careful because area is measured in squares. Okay, don't forget that. Area is measured in squares. Perimeter is not measured in squares. So now let's go over to the next part, number 2. Okay, I'm going to pull this over so y'all can see what's happening here. We're on the same page, and this is what my notes look like so far, okay? And so I'm going to pull down. Now, you already see the answer for number 2. It's right here. My teacher's edition has the answer already. So that just shows what we're supposed to get to. What I want you to do is just show your steps if you can, okay? So we've got the height of the rectangle is what I want to find, in which area is equal to this. So in other words, I'm going to start off with a triangle, parallelogram. And I know the area is 10x, what's that say, squared? I'm having to read it from across the table. And the base, it says is 2x feet. Okay, and then I need to know this height, which by the way is at a right angle again, so that has to happen. So what's the formula? Area equals BH. So that means area was 10x squared. My base was 2x, and my height stays h. So what's going to happen is I'm going to have my answer h is going to be in terms of x. So what happens here? You're going to divide both sides by 2x. Okay. Now remember, yesterday we talked about dividing like terms with exponents. This is really an exponent of 1 there. Okay, so 1 minus 1 is 0. That's when you hear the word cancel out. And 2 minus 1 is 1. So in this case, my answer is going to have an x value with an exponent of 1 there. You don't have to write that because it's understood. And 10 divided by 2 is 5. These cancel out, like we said, 2 divided by 2 and x divided by x. So we have h. So h is equal to 5x. All right, so that's 5x what though? That's 5x feet. So make sure you put the units there every time. Okay, so let's go to number 3. Come over here to the left. Let's see how much time we've got. We've got about 6 minutes. We could probably do about 3 or 4 more questions really quick. So we're going to talk about the perimeter. Perimeter of a square. Now we all know what a square is. A square is equal on all 4 sides. So if they give us the area is equal to this, how am I going to find the perimeter? So let's draw this out. Okay, so my area is equal to 169, but the perimeter is all of this. If you walked around the square starting from this point and came back to your original location, how long is that? How long is that? How long is that? They're all the same length. So if you'll notice, you can say that's x, 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 and x. So that's going to be 4 x's. Perimeter is equal to 4 x's. Okay? All right. Now, what is x going to be? Well, x, if you'll notice, this is your base and this is your height. So your base and your height are the same thing, right? So the area is equal to base times height. Area is equal to x times x. Area was equal to 169, and so x times x is equal to 169. What in the world? All you have to do is square root, all right? So if I rewrote this, it would be x squared equals 169. In order to solve for that, you square root both sides, and you get 13. So x is 13. So in other words, the square is 13 on every side all the way around. Now remember, the perimeter is 4 times x. So that means the perimeter is going to be 4 times 13. And that's 40 plus 12 is 52. So it's going to be 52 centimeters only, not centimeters squared, because we're not squares around here. We're just taking a distance around the shape. The squares are inside the shape itself. That's the area. So if you were to mark it out with the squares like this, you could count all these little squares inside of here, and that would be 169. All right, we got enough time for maybe one more question. So what do my notes look like so far? What am it looks like this. We're going to probably do one more question right in here and then wrap it up. I might do a little quick ACT problem until the thing cuts me off, just kind of as a refresher. So let's go to number 4. I'll tell you what, let's do number 4. Number 4 is area of a trapezoid, okay? Area of trapezoid. Now, what's the formula for the area of a trapezoid? Okay, it is area equals 1/2 Remember, a trapezoid looks kind of like a triangle, okay? And remember, it also has two bases. You add those two bases together, and then you multiply it by the height. So area equals base times height for a parallelogram. But in this case, it's like a triangle because it looks like this. It's got two parallel sides here. That means parallel. So we have one base here and one base there. And we need the height, which is an altitude at a right angle. And that's my height right there, okay? And so now let's go to the next part here and say what it says about the bases. So if you'll notice over here, our height is 20 and our two bases are 9 and 15. It's turned on its side. So we're going to say our bases are 9 and what was it, 15? And then the height was 20. So if we were to write it out like that, like if you were to turn this on its side, I guess, kind of like, I don't know. We're just going to go with it. So we're going to go with area equals 1/2 times 9 plus 15 times 20, okay? So 9 plus 15, that is 24. Half of 24 is 12, and 12 times 20 is 240. So that's going to be 240 meters squared. Let's double check that with my answer in the book. 240 meters squared. So we did actually do that correctly, okay? So now there's my final part of my notes, and that's all I'm going to expect you to do. And I'm going to end it today with a ACT question. All right? So pause your screen right there if you're doing the YouTube thing, okay? And then until this day end, until this video ends, I'm going to leave this up on the screen just like this. All right? So this is your ACT question. I'm going to talk about this a little bit tomorrow, or Monday, I'm sorry, when we get back. Monday, Tuesday, and Wednesday is when we're going to work, okay? So same time, same everything. We'll see you then, and y'all have a good week, okay? I'm going to let it play out. Y'all can figure this out if you want. And I'll pull down that last little problem so y'all can see that too, in case y'all didn't get a chance to write that down. Guys, it's good to see everybody this morning.
That's great.
All right. Okay, I think that's going to be it, guys. Y'all have a good day. And if there are any other questions before you leave, please talk to me if you need me.